Hey guys, this was Nelson. Today you're going to be doing notes over identifying additive and multiplicative relationships and then being able to go from a table to a graph to show that relationship. So if we look at the top, it says every state has 2 U.S. senators. The number of electoral votes a state has is equal to the number of U.S. senators and U.S. representatives. And it says the number of electoral votes is blank to the number of representatives. So if we look here at the table, we have to look and see what my relationship is between my 1 and my 3, my 2 and my 4. Okay, so if you look at this, you start thinking, what can I add that'll be the same each time, or what can I multiply that will be the same each time? So the easiest thing to see is that from 1 to 3, I added 2. From 2 to 4, I added 2. So the number of electoral votes is 2 more than the number of representatives. So if we complete the table, if I do 5 plus 2, that gives me 7. 25 plus 2, 27. 41 plus 2, 43. Okay? So to come up with a rule, which is the equation, okay, you're going to describe the number of electoral votes is equal to the number of representatives plus, and then we said that it was going to be 2. Okay? So in this case, this is because we are adding 2. This is going to be an additive relationship. Okay, so let's look at B. It says Franny orders 3 DVDs per month. So each month she's going to order 3 DVDs. So that we know if each month it's 3, then we're going to be multiplying. So if we look here from 1 to 3, from 2 to 6, I could add 2 here, but if I added 2 over here, it would still give me 4. So I know that that's not the choice that I want to do. And if it's 3 per month, I am multiplying by 3. That's the only one that works for both. So if we come back and finish our table, 4 times 3 is 12. We do 13 times 3. You get 39, and 22 times 3, and you get 66. So the rule is the number of DVDs ordered is equal to the number of months times 3. Each time we multiply times 3. So because up here we multiplied by 3, this is a multiplicative relationship. Okay, so then if we look, it wants us to reflect what operation did you use to complete the tables in A and B. So A, we added, so that's additive. And in B, we multiplied, so that's multiplicative. All right, so now we're going to look at some examples. So it says, Jolene is packing her lunch for school. The empty lunchbox weighs 5 ounces. Graph the relationship between the weight of the item in Jolene's lunch and the total weight of the packed lunch. So if an empty lunchbox weighs 5 ounces, okay, that means that anything that I add to my lunchbox, I'm going to have to add 5 to get the total number of what it equals. So our equation is y equals x plus 5, because we know that the 5 is constant. That's how much the lunchbox weighs and any other weight that we put in. So whenever you are making a table, I like to start with as close to 0, 0 if 0, 0 is going to apply. Okay, so in this case, the weight of the items is x and the total weight is going to be y. So whenever we write our equation, I'm going to choose a number and I'm going to plug in. So if I plug in a 0 where the x is, then I would say 0 plus 5 gives me 5. So that means when my lunchbox is empty, it'll weigh 5 ounces. If I put an item in that weighs 1 ounce, I plug the 1 in where the x is over here. 1 plus 5 is 6. If I plug 2 in, 2 plus 5 is 7. 3 plus 5 is 8. 4 plus 5 is 9. So, and again, you don't have to start at 0 and 5. We could have started at any point. Whenever you plug into the equation, then you're going to get your answer. So, it wants us to list the ordered pairs. So all I'm going to do is take these combinations that are here, and I'm going to write them in parentheses in ordered pair format. So my first point is 0, 5, then 1, 6, 2, 7, 3, 8, and 4, 9. Okay, so you see I have 5 ordered pairs. So to graph it, we're going to put a point on the graph where those are, and then we're going to come back, we're going to label our graph. So what you should remember is you always go left or right and then up or down. So this is a blown up image of quadrant 1. Okay, so we're positive, positive. So from 0, I start here at the origin and I go up 5 and I put a point. I have 1 to 6, 2 to 7, 3 to 8, and 4 to 9. Okay, if I draw a line that connects all these points, you notice that it does not cross at 0, 0, which is down here. So since it does not cross at 0, 0, then that means that this relationship is non-proportional. And this is something that you're going to hear me say a lot as we get further into relationships. And it is non-proportional because line does not go through 0, 0. Okay, so if we go back over here, if we look at our equation at the top, we know it was y equals x plus 5. Because we were adding in our equation, this is an additive relationship. Okay, so let's come back over here and we're going to graph our labels. We know that it's the weight of the item and the total weight. So my x-axis across the bottom is going to be weight of item. In ounces. And the y-axis is going to be my total weight. Again, in ounces. Okay? All right, so let's go to our last page. We're going to do the same thing. So it says, Oscar sells bracelets for $2 each and donates the money. Sorry again. And donates the money that he collects to a charity. So $2 each, that's important. Graph the relationship. Okay, so if each bracelet is $2 each, then my equation would be y equals 2x. Okay, so if I come over here, if I sell 0 bracelets, if I plug 0 in for x, 2 times 0, I make $0. If I sell 1 bracelet, 2 times 1 is 2. 2 bracelets, 2 times 2 is 4. 3 would be 6, and 4 would be 8. And again, you didn't have to start here, but I'm starting here in this table in order to show you something very specific about our relationship. Okay, so if we look over here, we're going to list the ordered pairs, just like we did on the previous page. I'm going to put them in parentheses, put them in the order that they show up. 3, 6, and 4, 8. Okay. So I'm going to graph these ordered pairs. So if I come down here, I know 0, 0 is going to be 1 point. So right here at the origin. And then I know 1, 2, 2, 4, 3, 6, and 4, 8. So what you notice, this graph is a little bit more spread out. So if I draw a line and connect these, you notice that I still go through the origin. So this relationship is proportional because the line can pass through 0, 0. And I say can because had I started my points higher up, I would have to extended my line for you to see that it would in fact pass through 0, 0. So also with our equation, since it was y equals 2x, this is a multiplicative relationship. Okay, so let's come back over here and let's do our labels. So this is going to be bracelets sold. And this is going to be total donation, which is going to be in money. All right, so if you have any questions, make sure you come tomorrow ready to ask. Bye.